Hello friends, welcome back to my channel. In this video, we will see how to find the constant in the given density function expression and how to derive the distribution function from the given density function. So this is the expression fx of x is equal to k into 1 plus x square. The interval over which it is defined is from 0 to 1. So we know the property from the property of the density function integral minus infinity to infinity fx of x dx is 1. So this is nothing but the area under the, this is the property area under the density function curve under the PDF is area under the PDF is 1. So this is the property that we will use whenever we ask to find the constant from the given density function expression curve. So here we have to change the limits because in the problem statement the limits over which this density function is defined only from 0 to 1. So instead of minus infinity to infinity, our limits are from 0 to 1 and the density function is k into 1 plus x square dx is equal to 1. So why we are substituting 0 to 1? Because the density function is defined in the interval 0 to 1 only. So that is why we are substituting the limits 0 to 1. So k is a constant, so it is independent of the integration, so it will come outside the integration. So it is simply 1. Integration of 1 dx is simply x plus integration of x square is x cube by 3, and we have to substitute the limits 0 to 1, so that is equal to 1. So k into, if we substitute the upper limit 1, so in place of x we have to substitute the upper limit 1 plus, here also it is 1 by 3. 1 cube means it is simply 3. So if we substitute the lower limit, anyway it is 0 plus 0 by 3 is equal to 1. So if we simplify k, if we take the LCM 3 plus 1, so it is k into 4 by 3 is equal to 1. So from this k value, the constant value that we have to find out is k is equal to 3 by 4. K is equal to 3 by 4. So this is the first part in this problem. Second part is we have to find the distribution function. Density function is given. We have to find the distribution function. So we know the relation. We know the relation from density function and distribution function is distribution function fx of x is nothing but integral minus infinity to x fx of x dx, fx of x dx. So here again, so the lower limit is not, while substituting the lower limit, the function is defined only from 0. It is defined only from 0. So that is why here we have to replace the lower limit with 0 x, and the constant that we have found out is 3 by 4, and then we have to substitute the remaining expression. So 3 by 4 into 1 plus x square into dx. So this constant we can take outside 3 by 4. Again, integration of 1 dx is x plus integration of x square is x cube by 3, and then we have to substitute the limits 0 to x. So it is 3 by 4. Again, if we substitute the upper limit, it is x, and again if we substitute, it is simply x cube by 3, and lower limit if we substitute, anyway it is 0. So this is the thing. So now if we simplify further, it is 3 by 4. If we take LCM, it is 3x plus x cube by 3. So 3 we get cancelled. So fx of x is simply 3x plus x cube by 4. So this is the expression for the distribution function. So here what are the things that are required to solve this problem? So first thing is we should know the relation between the distribution function and density function. This expression fx of x is equal to integral minus infinity to x density function fx of x dx. The other important thing that we should know is the area under the density curve is equal to 1. So these are the two things that are required in order to solve this problem. I hope everyone is understood the problem. If you have any doubts, you can comment me or you can ask the doubts in the comment section. Thank you for watching. Please subscribe to my channel, share with your friends and classmates. Thank you.